Hi guys, first of all remember I'm recording live, so you might wanna play it in twice the speed so that it's a bit more exciting on your end. So also what we want to do today, here's a bit of the agenda. So we first want to set up our project structure. That's also might be a bit less exciting for you, but still, I mean, there are some nice links and best practices that might be interesting for you as well. So let's kick it off. So I mean, the first thing is obviously we want to create some project structure, and I'll go into the terminal here. Also here, maybe noteworthy, I'm using Terminator, so it gives you the flexibility to have multiple tabs, but also kind of what is important usually is that you can see the Git branch once you're at it. Okay, so what do we want to do? There's something called cookie cutter data science. So let's quickly jump to the page here. So basically what you get is a standardized project structure for a data science project, and that means like usually you have notebooks for the visual output, you have some folder for the background code, and you also have some structure for models and all that stuff. And I think that's something that I usually use as my starting point. Start a new project. What we need to do is basically type that command here and then set up our structure. So is it okay? Yeah, we re-download it because we already have something cached. So what will be our project name? Let's think about that. So it's speech to text scratch project, a bit of a long project name. So speech to text is what we kind of want to do, but also this is just the early version, and so it's will be a bit of hacky code for now, and that's why I call it, like this scratch environment. So let's just copy paste that. The repo name is fine for me as well. Christian Grohl is the author name. Description, yeah. Some text to speech, sorry, it's the other way around. Some speech to text, Python experiments for now. Okay, then I usually use the MIT license, not super expert on that, but it's a very permissive license, so I'm totally open about the code that I'm using, so seems to be appropriate. I don't need to have a S3 bucket for now. Like you could, if you have more data in your project, then you kind of could use a cloud solution to store the data. That's why they are asking for the bucket. Python, I'm using Python 3. And now we seem to be good to go. You can see here we have this project, and that's where we want to go in. And then you see a lot of initial setup. Let's look into the file browser. So research and then speech to text, and yeah, like I said, kind of here would be where you store your data. So usually you kind of have the very raw data and never touch it again, and from that you get to processed or interim solutions or whatever. Then here's something for models, notebooks, and all that stuff, and here is where the code will reside. And so let's then also, like second step, get everything under version control. That means I'm usually using Git for that. So let's just git init, and then I'm still from the old days. I'm a Emacs user, in particular when it's about Git, because I have a somewhat nice overview here. So these are all the new files. So we have a README, we have a license file. So this is what you can see here. The MIT license, what we talked about. Let's basically just stage all of these. Commit initial commit from data science cookie cutter. Okay, good. enough for now. Then we also need to set up our computing environment. So kind of the first thing that we want to do is we want to record audio and get it as a .wav file, and I will use kind of that code snippet here. So here I can already see some packages that I need. So what we now want to do, we want to create a virtual environment. So kind of, if you've never done that before, you don't want to have one global Python installation where you install the packages, because for certain different projects you might need different project or package versions. So like the newer version in this project and the older PyTorch version in that project. So always try to have your own computing environment for every separate project. So that's what we want to do now. So I usually do it with here kind of virtual environment. I've already pip installed it. So here I create my user bin python 3 venv, so I don't have a just Python called binary on my machine. So that's now created. Let's see, we see also here the virtual environment folder. So now what I can do is I pip install into that. And so where were the packages? So the cookie cutter we don't need anymore. Here, pyannote. And the next thing will be wave. I think they in the, okay, that's obviously not good, which is required. Could not build wheels for as always, the demo gods. I'll stop for a second. Can I also pause it? Let me just, I'll pause it. Alright. So very first, very stupid mistake. So we created a virtual environment, but we didn't activate it. So now it's activated. You can see it here. Also, like I said before, like this is, you can see the branch of the of your Git repository as well. So let's try again. Maybe it was just a problem in the global environment. No, okay. Let's stop again. Et voila, now it worked. So I basically just googled the error message, and then here you can see, I mean, there are some system requirements that you should have up front. So I basically just installed that, and after that I could just pip install pyannote and it worked. What we also want to do, so let's kick off that project in Visual Studio Code, which is right now at this point in time my favorite IDE. So kind of open folder, speech to text, there we go, and then I think we should already have a requirements file. So this is basically a very nice hack already, so that everywhere in the project you can use the code in your source folder, because you kind of install all of this as a local package, and they are usually using also some other packages always, like for code coverage, for documentation, the client to connect to AWS, and yeah, so I think we don't need them for now. But what we definitely need is kind of pyannote, and what else did we install? This wave package, I think. Pyannote, let's search for it. Yeah, wave. Okay, and so kind of maybe one remark to that. So basically, whenever you type those commands, you more or less kind of the Python tries to install the latest version of packages. And so if you kind of run the same commands like pip install pyaudio like 6 months in the future, then you will very surely end up with different packages. So now we kind of want to preserve the computing environment that we have, and kind of it worked, everything kind of did install correctly. So what we want to do is like immediately preserve that computing environment. So what we can do is pip freeze, which means like look up all the package requirements that we, all the package versions that we have right now and write it into a file. And I usually write it into requirements frozen. Then let's look at that file. And here, okay, did we not yet install wave? Okay, let's give it another try. Pip install wave. Then let's freeze again, and yeah, there we have it. Okay, so kind of with that now, with this file, you could replicate basically my compute environment. Okay, now we have that set up. I think that's it for now, and then let's try the next step to record something. I'll stop for now. See you later.